Buenas tardes, Colombia. Muchas gracias a los organizadores por invitarme. Voy a dar la presentación en inglés, pero si al final alguien tiene preguntas en español, las puede hacer en español o en inglés, en lo que prefieran. So let's start. My keynote is on data science, past, present, and future. And just a little bit more about me. I finished my master's in 2011. I did it in Germany at RWTH Aachen, and it was on simulating electrical networks and figuring out where were the hotspots, in what places the voltage was susceptible to collapse. I then went to work for Procter & Gamble as a process engineer. At that point, there was still no one's said data science, but there was still a lot of data science being done to try to optimize productivity in manufacturing plants, for example. Because I did a lot of data analysis, I then went to work for a bank, and I was a business analyst and consultant. And then I made the jump, and I actually moved from Spain to the US in 2014. And I was a data scientist and product manager for Anaconda for almost 4 years. And then just recently, 4 weeks ago, I started my own data science consulting company called Datna. So data science has a lot of different angles. I usually think of it as three different components or three different ways of seeing data science. There's from the more academia and research perspective. Then there's the applied data science in industry and enterprise. And then there's this community and open source around data science as well. And I think each of us might fall in a different place. So my perspective is actually somewhere in between industry and enterprise and community and open source since I've been working with Anaconda for a long time. And I was leading the enterprise data science platform. So I got to see a lot of companies implementing their new data science processes, but then also being very connected to the community that Anaconda has built. So before we start, I know that for a lot of people, when I've mentioned I'm going to be giving a talk on data science, they were like, well, this term doesn't mean anything. It's been used too much, and so it's kind of lost all its meaning, and it's just another buzzword. And I want to correct a little bit that view. I think it still has value as a term, and we'll see a little bit how I use it and how other people might use different terms to define other things. So I like to think about data science as a workflow of data, and starting from the step of gathering, collecting, and storing that data, all the way to really understanding deeply what data you have, and exploring, cleaning it, transforming it, and also visualizing. There's then the third part of this cycle, which is the modeling, the part of building and validating models to classify, to predict, to infer. And then I also think it's part of the data science workflow to deploy those solutions either embedded into products or as machine learning REST APIs, or back into the systems that you have in place in your company, databases, CRMs, etc. And how do you use that information to make business decisions going forward? So there are some different roles that have emerged in the different organizations that form kind of the whole data team. And we see this new terms of data engineering and architecture, people that used to have more of a background on DBAs and data warehousing, and now fulfilling those roles. We have also people that used to have more of a background in business intelligence or domain experts that now are learning more statistical models or other tools and are kind of becoming data and analytics experts. And then we have the data modeling phase, and that's something a lot of people see as equal to data science, but I like to see the data science as the whole workflow instead. And I just call that part data modeling, and it's typically done by the term data scientist. So if we take a deeper look onto this third phase, what we call modeling, We have systems and methods in machine learning that can help us do that type of modeling. And we have basically 3 groups, what's called unsupervised learning, supervised learning, and then reinforcement learning. And each of those has differences, right? Both in like the tasks, the applications, and the algorithms that you use to implement them. And basically, this morning we already saw a little bit we heard a little bit of the difference between unsupervised learning and supervised learning. And when supervised learning, you usually have those labels that you want to classify or you want to predict quantitative value, and you do regression, for example. Whereas the unsupervised learning, you don't have those labels, and you're just trying to explore your data and find meaningful patterns out of it. And that's when you do things like clustering or dimensionality reduction. And then I think it's really interesting, and probably a lot of you have heard about reinforcement learning recently, and how you evolve that exploring and making predictions to actually how to make decisions with that data, with those insights that we find. And so we have those tasks, the exploration, predicting, and decision making. And then we have different applications that we find in business or in the industry for each of those different types of learning. For example, in unsupervised learning, you can do things like marketing segmentation to better target your customers, anomaly detection for things like fraud, or summarizing information. For supervised learning, the typical example is the spam filter, what we saw this morning as well of object and face recognition, and then things like recommender systems as well. And then finally, in reinforcement learning, we have things like defeating Go champion that was like the biggest news last year, or things doing like automating trading strategies. And then I'm just not going to go through the details of all the other algorithms, but you can see that there's other algorithms for each of those different types of learning. And then if we look into deep learning, and we already went into a little bit more depth this morning, is when you have neural networks with multiple hidden layers, those kind of group of algorithms we call deep learning. And so my definition, which is a very data science-centric definition of those terms, start with like the broader of like data science workflow. From it, one of those steps that we call modeling can use machine learning. And then one type of machine learning that uses the neural networks we call deep learning. For different people, they use the term AI to mean different things. For some people, they equate machine learning to AI. Other places, you'll read that deep learning equals to AI, and in other news or papers, you'll see that people refer as AI to reinforcement learning. I'm just like gonna mostly avoid talking about AI, just because I'd rather be more specific in which of those tasks I mean when I say AI. So now that we have kind of the ground set, let's look a little bit about the past, how we've come to where we are today. And so let's start looking at like how was the term data science coined. And one of like the big news or articles that started making this term popular was this one that's already a few years old. In October 2012, was published by DJ Patil and Davenport, calling like the data scientist the sexiest job of the 21st century. In this article, they actually refer to when they coined that term between DJ Patil and Jeff Hammerbacher. And that's when they were both kind of heading these data and analytics teams at large internet companies like Facebook and LinkedIn. And so basically, what's interesting though is it's not at that point, 2018, when just this term appeared and people started doing things with data. People had been doing things with data for a long time before that. Analytics, reporting, dashboards, BI, what was called previously data mining, operations research, applied statistics, had been there. People had been doing those things. We had quants in finance that were already doing a lot of modeling and trading. We had a lot of the DBAs and data warehousing, people worrying about how we store data. So what was different in 28 for this term to like now appear in our world. So basically, it had to do with three things: the skills, the data, and the tools. So up till then, there were no people that really could have that interaction between these three different areas. So if you were like a DBA, you knew a lot about the data, but you probably didn't have math skills or programming languages. You pretty much knew SQL and how all those databases worked. And similarly, for people doing BI and analytics, they probably were domain experts and knew some basic statistics, but were lacking more of the this hacking skills and coding. So for the first time, we see this like three skills coming together, and these people starting to arise. It's also kind of the first time or when we start noticing that we have a lot of data that we've accumulated, and that we can start analyzing and finding deeper insights than what we were doing with just reporting for the rest of the business. And then also very important are the tools, the open source tools, and we'll see how the appearance of that community and those libraries had an impact as well for data scientists to be able to expand and exist and kind of take over this like data insights finding role in companies. So there's different definitions. One of the first ones I saw at PyTexas, I think it was 2013, is from Josh Wills, who worked at Cloudera, and it was kind of like this joke where like a data science, a person who's better at statistics than any software engineer, and better at software engineering than any statistician. And actually, just recently, I wrote this blog article that I found very interesting, which was about imposter syndrome and how different people feel like, oh, I don't know if to consider myself a data scientist or not. You're supposed to be this unicorn that can do like Spark and Python and maybe sometimes Java and and Scala, and they throw it to you, and I'm not really that person. And so I really resonated with Brandon, and there's so much new methods that are coming out every day, deep learning and all these new applications. And it's hard for people when you're working full time to keep up with everything that's happening with all the new open source libraries that are being thrown out there and being comfortable with all of that. So I think it really resonates with me that if you're asking questions and using data to find answers, you are a data scientist. And period. So before data science, how were people analyzing data? So this was my experience working at both at a manufacturing plant, doing data analysis, as well as working at a bank. And basically, this was our tech stack: SAS, Oracle, Matlab, and Excel. And kind of like my day-to-day looked like that, with people sending me files that had these connectors, and they were supposed to be processing data, and you had to double-click to see what actually was happening. So debugging that was a nightmare. And also had other challenges, like transparency. I had no idea what this flow might do. There were problems with innovation. All the methods that were coming out in the open source was very hard for a commercial tool to release at the same speed. Dealing with large amounts of big data was also hard for those companies to support immediately. Then were problems with reproducibility. Someone sent me this file on an email, and then there was no way I could get the same results again. And then deployment, right? We have this very inefficient way to compute things, and now someone asks you, well, let's build an application so we can consume what you found in your data. And that was impossible. Not to say that it was also very costly in terms of the license of those 4 commercial tools as well for large organizations. So looking more deep into the tools, let's take a look, how we got here where we are today, where, pretty much with 4 lines of Python code, we can classify images of objects with 95% or more accuracy. And that can do any of you here right now could do that. But in order for us to be able to do that, we are using tools that have been built by a lot of people, by contributions by a lot of people that have been working with this for a very long time. So we need to like acknowledge that it just didn't like appear one night. It was like a continuous like contribution for many years, for many people, for this community, Python community to build, and other people to build on top of kind of those foundations. So we have to think like the first version, the 1.1, 1.0 of Python was released in '94. That's 14 years ago. So it takes time. And then, a few years after that, we're starting to see the like foundations of data science and the scientific community libraries like SciPy and IPython and Matlab and NumPy. And then, between 2006 and 2014, we really like saw a big growth on other libraries leveraging those foundations, those data structures, those methods to build more sophisticated tools to do data science, machine learning, data wrangling in pandas. And then I also think that Conda and Anaconda contributed into making it very easily for anyone to install those libraries and get up and running really fast. And then kind of IPython also became kind of language acknowledged and turned into this Jupyter project that also supported multiple kernels, not just Python. And that has also helped the data science community be more language agnostic and embrace other languages like R and Julia and Scala. And then what's interesting in like the last few years, those kind of like early open source projects were mostly done by academics or grad students that really wanted to implement in Python in open source things that maybe were just like possible using commercial tools, and that sometimes there was at the cost of doing their own research. But then like things recently have really like changed where a lot of the development of open source is actually being led by companies and employees that are being paid by those companies to work on open source. So that's also a shift and a change. And sometimes it's being used to encourage people to join the company, right? Like, let's all work on open source. Everyone wants to work on open source. Let's go work for this company who's releasing all these open source projects. At Anaconda, there's open source developers. Also, Airbnb has released things like Airflow for data management and kind of pipeline management. And then TensorFlow is being developed at Google, PyTorch at Facebook, and then Pyro at Uber. So this is like also an interesting change on how is that impacting open source and open source development. And we're actually all building on each other's work, so it's very important to see that we're getting to like higher levels of abstraction. This is like a graphics that Jake Vanderplas usually like gives in his talks, and we can see how we're kind of like abstracting at every layer a little bit more, and kind of building applications that are more specific to domains like AstroPy or BioPython, and we'll see that as well in the deep learning space in some examples in a few slides. And another thing that also happened to us as consumers and users is like we became very comfortable, or we became very accustomed to incorporating those data products in our day-to-day life, right? So this is like now how we consume information, how we buy products, what shows we watch on TV, how we navigate, how we connect to other people. All of this is based on data science and products that mostly leverage data to build their products. And it's kind of like hard to manage, but it was like already in 2009 when Netflix awarded like that recommendation algorithm $1 million prize. And it's already like 9 years ago. That was a big thing and made also kind of data science and machine learning pretty popular and in the industry. People are like, oh, you can make $1 million by writing a machine learning algorithm. And so I think something to think about is that it's very easy for us to now say, oh, all these projects helped us build this data science community and helped us now be able to do deep learning, machine learning very easily. But every of those projects, when they started, it was a big endeavor, right, for someone in academia doing some research saying, oh, I'm going to implement this random number generation, I'm going to package it, or this fast Fourier transforms and package it. So I think it's important to realize that every project started with a very small first step. And so all of our small first steps might have consequences long term that we can't really acknowledge today, but that are important and can make an impact. So let's take a look at what's the data science presently, in the present. So right now there's Gartner, this analyst company that publishes what's called the hype cycle. And basically, it has this curve that starts like when innovation starts, the peak of inflated expectations, and then disillusionment, and then some enlightenment, and then when that technology is in its most effective productivity. And right now, on the top three, we have deep learning, machine learning, and autonomous vehicles. That's the hypest things there are right now in technology, according to Gartner. So I think it's true that it might be a little bit hyped in some news, etc. But it's also true that it's actually changing organizations. And it's actually true that that kind of solo data scientist that was hired to start doing more with our data, whatever, build models, is now actually becoming a new profession and a new career path. And now we're seeing the explosion of also data science manager titles, directors of data science, that a few years ago didn't exist. So we're building this new career that I think is going to continue, because the data science term is actually how do we use all this new functionality that exists to find better and more meaningful insights in our data. And so I think more than hyped, data science is starting to mature, and it's maturing in different areas, both in the ecosystem, the skills, the open source, the compute possibilities that we have at the reach of our hands, and then the data and algorithms. So let's look a little bit on each of those. So the ecosystem, I refer to that to the products and the vendors that exist, that are now being able to serve through this early maturity of businesses. And some usually signs of an industry maturing is this consolidation phase of multiple startups being acquired by larger ones. And so this has happened. Curie, Whitehat, Sense, Kaggle have all been acquired by different companies. Whitehat by Alteryx, Sense by Cloudera, Kaggle by Google, Curie by Apple. And then we also see some IPOs of this big data science vendors as well, like Cloudera and Alteryx. So those are signs of the industry maturing. Another thing is, because this field was also very new, universities were not really prepared to define their new curriculums. And what we saw is actually data science was kind of one of the first roles in that really leveraged the online learning, right? So you can see a lot of data science content in online learnings like Coursera, Udacity, the deep learning AI. And then there are more recent findings that I found. One that I really liked that's called Fast AI. And actually, Fast AI takes a very different approach to, if you've done any of the machine learning in Coursera or deep learning AI, it takes a very hands-on coding first and seeing the results and the applications to begin with. And then slowly you start understanding all the different parameters and all the different, you go in depth in the different algorithms. But you start very basic, learn 4 lines of code to be able to classify images with very high accuracy. And when you see that, you're kind of very encouraged to keep digging down and deeper. Whereas if you start with more of theoretical introduction to machine learning, deep learning, for those of us who might have been out of school for a while and have been really practicing and coding might be a little bit overwhelming. And so starting with a fast AI, which is really targeting to coders and just like coding and then introducing the concepts as you go, has been very beneficial in my experience. And then there's other companies that, like DataCamp, that follow similar approaches, which is all about like leveraging Jupyter notebooks to learn as you go, and really like typing, and instead of just like listening to videos and kind of theorems and methods, but actually just like applying it from the start. And I also saw that MIT just like recently published their Intro to Deep Learning courses online for free. So that's also a link that you probably want to check out. And then kind of larger companies like O'Reilly also have subscriptions for larger enterprises and have what they call the Oriole online tutorials, which also follow a similar pattern than DataCamp, and which is like providing you with a platform where you can like code and do the tutorials online with a Jupyter notebook-like interface. So that also has opened the data science field to a lot of people, new people, and because like there was no certificate from a university saying, oh, I'm a full stack data scientist, whatever that might mean. It's also brought a lot of diversity in terms of backgrounds for people that are currently data scientists, people that are coming from a machine learning academics background, people that are coming from the business, kind of analytics and kind of learning coding on their own. And then developers, open source, that might have been developing code and then learning how to like build these other machine learning algorithms with, for example, Python. So then it was also interesting to see how this like kind of boot camps popped up, Galvanize, General Assembly, Data Science Dojo, and then how a lot of universities have also started to adopt the term data science and started building degrees, undergraduate degrees, and grad programs using the term data science. It's actually pretty funny because my master's degree was called in data mining and business intelligence, and now they just like rebranded and call it Masters in Data Science. So the change is real. And so the other thing, the maturity is in the open source. Those initial libraries, those foundations that we had are now becoming more mature, more used. New technologies for deep learning are becoming accessible. We have to think that PyTorch just turned 1 year old recently, just in the month of January. So things are happening at a very high speed, and new technologies are becoming available to us. And for a very variety of applications, right? It's not just about data munging and machine learning, but for natural language processing, for big data, for data workflows, for statistics. We are very lucky to be in an ecosystem in Python where we have a lot of that functionality built for us that we can leverage. Another sign of maturity of an industry is actually seeing the big companies release products to support this new industry. And we can see different products, and I mostly classify those products in 3 types. We can see data science collaboration platforms being released. We can see their own kind of machine learning and deep learning APIs being released. And then mechanism or workflows for you to be able to build, train, and deploy APIs using also their infrastructure. So we can see, for example, data science collaboration environments are things like the Google Cloud Data Lab or Azure Machine Learning. Then we also have this already built machine learning and deep learning APIs, like the Cloud Vision API or the computer vision for Azure or the AWS recognition. So this is just they're already trained and built for you. So you can just submit an image and you get back the prediction of what that image contains. But then also, there's limitations of what their models might be able to do. And if you want to tailor it to your own application, then they also have systems like the Amazon SageMaker to support the building, training, and deploying with their own infrastructure. And then more and more data and algorithms are becoming available. There's data sets for audio, for images, for crawled websites that are open and people can download them and apply them. So if you are interested in an application, but don't work in that industry, you have data accessible for you and like large amounts of data to be able to learn those skills and apply them in real settings. And then also, there's kind of companies and tools like Kaggle where you can compare the performance of different algorithms and how people solve real-world challenges. And then also, there's this like a startup company out of Austin called Data.world that are actually building a big data repository where people can submit their data sets, and they can, you can see like traceability and download someone else's data set that is like a trusted entity that can like serve that data to you. So something interesting that happened this year, and I just like saw a few months ago, the documentary of AlphaGo, which was really good. So if you're interested in the topic, it was pretty interesting to see how that came about. But for those of you who might have not heard about AlphaGo, it actually started in 2015 when the first version of AlphaGo that they named after the player fan beat that Go player. And that was something that a lot of people thought it was like decades away from the technology to be able to accomplish, and it was able to do it in 2015. But then other people came, maybe he was not that good of a Go player, and so they said, okay, let's go and find a better Go player. And so they find Lee Sedol, which is a 9-dan professional player, which is like the top player you can be in Go, and they actually AlphaGo beat Lee in a 5-game match, and that really started, brought a lot of attention to it. And since then, it also in 2017, it beat another Go player, and then that version was called Master. And that's very interesting, is they just published this paper in October 2017, where this AlphaGo 0 was able to beat the AlphaGo that beat Lee, the 9-dan professional player, 100-0. And that means 100 times to 100 games to 0 games. And it was just using an algorithm that was using reinforcement learning, which was just not using any human data. It was just playing itself. So this was a very big accomplishment for the industry, and there's a link for the paper that explains how that was done. We also learned things like, that when we use the adversarial networks, it's hard for them to know if it's a Chihuahua or a muffin, if it's a Shar-Pei or a towel, if it's a Labradoodle or a fried chicken, or it's a sheepdog or a mop. So we learned fun things like that as well in deep learning. But then there are also real applications that happen in the industry, and there's very interesting things. And I just put a few. But there's this company that is using drones in AI to help to avoid elephants being poached. And you can see how it uses that drone and being able to recognize those images and count the elephants to make sure they're okay. Also, this Nature paper was published a year ago, where this machine learning deep neural network was able to predict skin cancer better than dermatologists. And then this very funny Japanese cucumber farmer that was using deep learning TensorFlow to better crop cucumbers and better classify the quality of the different cucumbers that he was farming. And then kind of in the data products, we've kind of moved from this internet services and kind of being comfortable with consuming those data products online to actually bringing kind of those devices, those data product devices, into our homes and into our, into ourselves with the wearables and watches. And those are also consuming a ton of data as well. And we'll see how, what can be done with the data that we produce. So let's take a look at what the future of data science means. So we're all very excited to see when it's like the autonomous vehicles are going to come around. There's a lot of research, there's a lot of competitioning happening between Uber and Google and all these like companies wanting to be the first ones to get those autonomous vehicles out, and they're already like some are already in the roads. In the open source community, just like a few weeks ago, Facebook also released, there's a new library called Detectron that allows you to also recognize multiple images and actually like crop them very finely to identify what image is in these different pictures and give you like a percentage of probability of what it actually is. But this like future of data science and deep learning and machine learning comes with some challenges that we have to acknowledge. Some on security, some on ethics, interpretability, and open source sustainability. And I'll just like talk a little bit, a few of each of those. In terms of security, I don't know if you've seen this one, but Strava released back in November an update on their heat map. And this is like data, public data that they gather from their users. And the users are athletes that they just like go for runs or do like sports and track their performance. And so, nothing happened for a few months, and then in February or end of January, there was this analyst that actually realized that in a lot of third world countries where people don't have wearables, you could actually like see a lot of places that they suspected to be kind of military US bases or secret military US bases. And there was some kind of debate on whether, well, if you're in the military, you shouldn't be activating your device to track your data so that then someone could plot where the base is if it's supposed to be secret. And so trying to blame it on the user for not understanding the terms of service and how public data works. But then actually there's also a link on an article that you can read on how it was actually pretty badly designed. How if you didn't want your data to be public, you had to go through 5 different loops to deactivate that setting. And so it was very hard for users to really understand what data that they were gathering was actually public versus private. There's other security issues like people trying to hack these AI systems. When you know how they work, you might start trying to win them over, right? So there's articles on how just by adding some stickers on the stop signs, they actually the autonomous vehicles don't recognize the stop sign and don't stop. And that could be a security issue. Also for face detection, we see this how they hack just putting yourself this glasses. The algorithm thought you were a completely different person. So it's interesting to start thinking about those things as we build AI systems. This was also pretty recent. This is actually just 2 days ago. There was a subreddit called Deepfakes, which basically used TensorFlow and substitute the face of porn actresses with famous actresses or any person you wanted. So this is a major ethical concern, right? Previously we saw, okay, we can swap Trump and Hillary and haha, it's really funny. But when we start building more systems like that in unethical ways, and they're starting to get very, very good to a point that it's very hard for a person to know what's real and what's fake. Then we start getting into less funny territory. And I just saw recently, just 2 days ago, Reddit actually banned that subreddit from their community. And then there's other things like bias. So there's this system in the US that was called Compass that basically judges would use to dictate what sentence you would get. And it was a proprietary solver. No one knew what the algorithm was doing. And basically, it could dictate whether you were going to jail or not. And then after the fact, after some researchers starting to dig deeper, they actually found that if you were a black defendant, you would have a higher risk like the system would predict that you have a higher risk of recidivism than you actually did, and if you were white, you would have like a lower one. And so that also brings questions on like how we use those systems and how those impact our society. And I think it's very interesting when you think about bias. And I read this blog post as well that was very insightful. That actually machine learning models will learn what the data shows them and then tell you what they've learned. So when we think about bias, it's not that the algorithm is biased in itself. It's like the data that we're feeding it is biased. And so those systems refuse to like learn the world as we wish it were. So it's not, we don't live in an ideal world. There are already a lot of biases that are intrinsic to our systems. So if we just feed that data back into those algorithms, we're just going to keep sustaining those biases in our world. So identifying them and then trying to like take corrective action so they don't act that way is something to be aware of. And it kind of says like the fact that these biases do exist in our society and they're reflected in nearly any piece of data you look at, and then if we feed that data into these algorithms, they're going to be biased as well. So there's initiatives to help define a code of ethics for data scientists. There's an initiative that's being worked with Bloomberg Data for Democracy and Bright Hive. You can find more information in those links. But kind of like how do we deal with these ethical problems that are going to come up as we do more AI and machine learning. Another big issue that has kind of been arising, or that you can hear a lot in the industry, is about interpretability and how important it is to be able to interpret what those models are doing. And it was interesting also in that same piece article where it says that actually we're asking machines to give us a reason on why they made that prediction or that decision, but we're actually, as humans, are pretty bad at it ourselves. So we are very good at explaining it, at explaining how we made those decisions, but it's actually after the fact, and we kind of put together this like reasonable sounding explanation for the decision, but it's very actually hard to see why did you actually do that. There's not like a specific, why did you invest this money into that company? Well, I just like felt like it, right? Like it's very hard to say what everything you've done in your life has like made you make that decision at that specific moment. So there's some efforts into building like systems and libraries to help better understand how those algorithms, specifically in deep learning, are making those decisions. But then there's also other people that kind of, think a similar way that if, it's hard for us to like understand like how we make decisions as humans. So we probably should do like optimize by accuracy instead of interpretability. And so there's this quote of, if you have to choose between an AI doctor that is 80% accurate but can explain you why he's accurate versus a 90% accurate but can't, this person in particular would go with a 90% one. But there's probably like debate on how people would feel more comfortable. Would you feel more comfortable saying to someone, oh, you need to get this like surgery because there's this and this factor, versus I don't know why, but you should get surgery. Right? This is like real problem that we're going to start facing. So my last challenge is around open source sustainability, and kind of we've seen how. We've kind of started with like kind of these individuals creating these open source packages that we all rely on and kind of like maintaining them. But there's a real developer burnout in the open source. We don't realize it, but it's actually like very few people maintain software that we all rely on. And there's like a big volume of noise that they have to deal with in very different forms, from GitHub issues to tweets, people saying, this documentation is terrible, and like from all this, like from emails, from all those different systems, and we don't realize that it's very few people. In major projects, it might be like 1, 2, or 3 people at most. And so that ratio, developer, user, is not very high. And so I think it's important for all of us to realize, I know that sometimes if you're a user, it can be very frustrating when you're trying to, like, someone says, oh, it's very easy to do this with scikit-learn or with, pandas or Matlab, and you start doing it as a beginner, and you're just like so frustrated, like nothing works. And you're probably right, and you're probably like, your frustration is real. But we need to start trying to convert that frustration in contributing back, both for ourselves on like a personal level, but then also as working for companies that can actually help sustain those ecosystems. Thinking like, oh, can my company pay for my time to contribute back, or can they make like a monetary donation? Because they are profiting without really giving back in a lot of cases. So this is something for you to think, how you can personally contribute back when that frustration arises. And then secondly, how can you help your companies contribute back to the open source that is helping them build their company and their success. So thank you very much. And this is my Twitter, if you want to follow me. And then if anyone has questions, either in English or Spanish, I'll take some now.
Hi. Well, the question is, how do you think the entire environment is going to develop, and how can we prepare to be as much prepared technically to engage these difficulties or these challenges that are coming?
As an individual developer? So one, if you're not contributing to like open source, I think that would be one for the open source sustainability problem. I think for, let's see, what other, because there's also, if you are interested in getting deeper into the field of deep learning and machine learning, I think there's a real value for people that have software engineering backgrounds or have developed software to contribute into implementing more machine learning, deep learning models. And actually, because we have all these like free resources like Fast AI and MIT courses that are very focused to like developers and engineers, but don't assume any machine learning or deep learning knowledge, I think most Python developers can get comfortable with deep learning and machine learning pretty quickly if they take those courses. So that would be another way to like enter and be more involved with the field. Thank you.
So first of all, awesome Keynote. Thank you very much. And I also want to thank you for touching on the ethics concerns on data science. So we are dealing with a hugely powerful tool, but Uncle Ben talk, with huge power comes huge responsibility. So coming back to that topic, what do you think we as developers and as people that are not very well trained on ethics can do in order to like at least take into account this ethics problem, and it's like and maybe try driving forward this conversation? Yeah,
that's a great question. So I think as developers, we have the responsibility to understand what we're building and what the consequences might be of that development, right? So if you're the developer building that heat map, understanding that putting all that data together might flourish some insights that might, have some security concerns. That's something that you're creating. So making sure that you understand, or that you start not just like understand, but dare to explore the consequences that it might have. I think that's like a starting point, right? And so feeling responsible of like the things that we build, and not just like, oh, someone told me to just like build this, but actually questioning those. And so I think this effort that they're trying to build the code of ethics is going to help us to like have a framework of, okay, these are the things that we're going to have to like look for. This is our like known things that could turn into issues, like data that has like some anomalies in some areas. That might be an indication that, well, then like data is not really anonymized if you can see exactly one person coming out from the same driveway every day, and you can link that data back to some published data elsewhere, and now you can like actually have most of the person's information of where they live, their social accounts, because you created that application, right? So I think that taking that accountability individually as developers is important. And then also for the companies that we work for, right? So I think developers, we're pretty lucky, and it's just like a growing market, and most people are well employed. So you actually, we are lucky in the way that you can decide who you work with in some degree. So that's also something that you can act on.
Hi. I have two questions. The first one is feature engineering or deep learning. Why and when will you use one or the other? And the second one is that I see many data scientists trying to work on algorithms and machine learning, but there is still like a huge gap in actually getting the data and cleaning it and transform it properly to analyze it. And on the end, to visualize it properly. So personally, I'm concerned because I see many data scientists doing machine learning, but very few actually working in preparing data and transforming it properly and visualizing it.
Yeah, I think, so to your first question, like when to use deep learning versus machine learning with feature engineering, I think it depends on like the application. I think we've seen like very good results in like applying deep learning. And you can try that first and see how it performs. And for other applications where maybe a client is not as comfortable with not knowing what's happening and having to explain that and then not trusting it, whereas like if you explain linear regression, they get comfortable. So sometimes it's like more of like a people problem than like a we don't always need to optimize for like the technology. Sometimes you need to optimize, okay, we can make an improvement in this company if we start with something that we can explain and we can get people comfortable, and then we can like take it from there. And then your second question was, let me think, was on data cleaning and visualization. Yeah, so I think it's, as I mentioned in the first workflow, I think the industry, we're kind of hyping it to making it the modeling part really cool, and it's like, oh, there's like, we have all these courses on modeling and machine learning and deep learning, and so because of that, I think data scientists fear that if they're doing anything else besides that, they're not going to be considered a data scientist. So you're trying to like, oh, I've done all this deep learning, and I'll learn this like new library, I can do PyTorch and TensorFlow and Keras and all this, but if I'm cleaning data, maybe I'm not going to be considered a data scientist in like a few, in my next job, or I'm just going to be like the data cleaning guy instead. So I think it's important for the community to, display that it's as important to do all the data cleaning as it is to, also like understanding your results and communicating them. And so visualizing also ends up being very important. So I think is how we communicate that and how we make sure that those other tasks are not thought as like second class activities or tasks for a data scientist, but they're also very important to do well. And actually, they do prove to be like significant improvements in accuracy when you do data cleaning correctly. And then you get also a lot of buy-in into like your client or your company when you can actually communicate and people can actually understand what's happening. And so visualization also turns out to be very important.
Hi, I would like to, first of all, thank you for your time. About this algorithm you present, the article, about how an algorithm can take you to show you how likely you are to go to prison. In our country, corruption levels are really, really high. Do you see this knowledge applied in the near future to make our government processes clearer?
Yeah, so that's a great question. I think that it's a real concern how we make sure that we empower citizens to hold their governments accountable using data. I think we're in like a global political situation where there's like just like basic things like what's a fact, and that it's very scary when you like start questioning those things. And then if those governments, are start to like not take democracy seriously, the danger is like then we might start like seeing these tools applied against citizens instead for democracy. So making sure that we held people in office accountable for their actions is going to be even more important going forward. I think social media was had a big impact on that accountability, but we are seeing how that that has been identified as a way to manipulating society. So it's being used for that purpose as well. So I think we could see similar things in the AI space, like with the example of when it becomes pretty easy to manipulate images and video. If we already are kind of seeing how manipulating text and information through like social media or newsletters is impacts like the society and what people believe. Imagine if we do that consistently with images and videos, the struggle that it could really be. So I think it's really important for, and I don't think it's just like Colombia that might have. I think you're probably right that like it has like a corruption problem, but there's a lot of countries in the world that also are pretty corrupt. And so yeah, I think that's there's organizations in the U.S., for example, Data for Democracy. They're based out of Austin as well, and they're trying to like work together on how we can use data to make democracies stronger and not weaker.
I wanted to ask you, what do you consider that are the skills that an informatics engineer should know at undergraduate level, and which skills should be taught at graduate level?
Okay, so what skills should be talking like undergrad and grad? Okay, so that's an interesting. I think I don't know if I would put like a line of like what if you're undergrad you just like need to learn these skills, and if you're a grad you need to learn these other skills. I think in general like grad it's usually thought as like a step towards like an academic career, or if you want something more go deeper into like a subject that you studied. But I think all the skills that a data scientist needs, from coding, statistical knowledge, to like communicating your insights, to basic understanding of like data storage and systems, should be taught at both levels, and it would be a matter of like in grad school how you can get deeper. I think supplementing a lot of that with there are so many free content nowadays online where you can learn kind of those coding skills and statistical knowledge. People publish a lot of that. That I think it's changing a little bit, like what universities should teach. So yeah, I don't work, as I saw my triangle, I'm like not very close to like the academic university world, so I'm probably not the right person to answer that question. Probably someone that's in a university should think about. Okay, thank you. Have a good rest of your conference.